right, so this is for the next one. So what do we got? What is the domain of the following rational expression? Express the rational expression in lowest terms. So a couple things we got to do. First, we need to find a domain. So the domain is pretty much what restrictions we can have for our inputs, for our x's. Well, because we're dealing with a rational expression, a ratio slash a fraction, our restrictions come in the form of what can we put that is not going to make our denominator 0. So I look at my denominator and I set it equal to 0. It's that simple. So now I just solve this. Well, if I look at that, I can factor that to this. And now I've got x equals 0, x plus 3 equals 0, which gives me x equals negative 3. So for my domain, x cannot equal 0 or negative 3. Now I know I put equals over here, but remember what I'm trying to accomplish. I'm trying to see what x's will give me a 0 in the denominator. So I set these equal to 0 to see which x's, 0, and negative 3 will give me 0, right? If I put in 0 here, 0 squared plus 3 times 0 is 0. If I put in negative 3 to the second power is positive 9. And then 3 times negative 3 is negative 9. Positive 9 plus negative 9 is 0. So those two things I can't have. Every other number is fine. Now I want to reduce to lowest terms. Again, so now I factor. So the denominator we already factored is x times x plus 3. But the top, well, that is a quadratic. And a quadratic I get by multiplying two binomials. So I look x to the second power, that's x times x, right? 9. Sorry, I had to take a water break. So what two numbers do I multiply to get 9, but when I add, I get 6? That's right, Kamaya. It is 3 and 3. Both my signs are plus, so both these signs are plus. Now, to finish off my problem, I just cancel because I can factor out or divide out an x plus 3 and an x plus 3. And so my final answer is x plus 3 over x. So the domain is that. My answer is that. Next. Simplify the following rational expressions by rewriting it with a single polynomial denominator. What the heck does that mean? It means add or subtract or multiply or divide my fractions. But I need a single denominator. So let's get to subtract. I need a common denominator. To get a common denominator when you're dealing with polynomials, for the most part, you just multiply the polynomials. So I'll multiply these two things. So my common denominator is going to be x times x plus 5. So if I'm multiplying these two things together on the bottom, then I got to multiply them on the top. So the bottom over here, I'm multiplying by x plus 5. That means on the top, I got to multiply 6 times x plus 5. And then this minus 3, I got to multiply that times x. So now I distribute that. So that's 6x plus 30 minus 3x over. Now notice I didn't distribute that because at this point I'm trying to see if I can factor. So right now I'm not going to do that. So that's x times x plus 5. So 6x plus 30 minus 3x, that's going to be 3x plus 30 over x times x plus 5. And then the last thing I need to do is factor. So I'll pull out a 3. That's x plus 10 on the top. So 3 times x plus 10 over x times x plus 5. There is nothing that I can factor out. So if it makes you feel good, you can distribute and get your final answer to be x squared plus 5x. So either one of those will be fine. Either the factored form or the non-factored form. So now I've got two fractions that I need to multiply. So that's x plus 3 over 5x times 10x squared over x squared minus 9. Well, I can factor these and do some reducing or cross canceling. So I'm going to rewrite this. And now I'm going to rewrite 10x squared to where I'm going to say it's 2x times 5x, because that's what give me 10x squared, right? And then I'm going to factor x squared minus 9, because what is that, Malcolm? It's the difference of squares, x plus 3 times x minus 3. So now that I got that, I can see that I can cross that off and that off. I can cross this off and this off. So now I see what's left. So on the top, I've got 2x. On the bottom, I got x minus 3. So that's it. Now, when you're dealing with a problem like this, you probably still want to check your domain, but the instructions didn't say it. So I'm not going to worry about it for that. But be wary of your instructions. Your instructions say find the domain, then you need to worry about it. If they don't, then don't worry about it. Okay. So next, now we got the composition of functions. So that's when I take a function and another function and I kind of combine them or put them inside of each other. So for this one, f of g of x, what I take is function g and put it as an input of function f. So g of x equals x plus 3. So I want to have f of g of x. That's what this special notation means. It means f of g of x. That is f of g of x. So that's going to be f is x squared, but instead of putting in x squared, I'm going to put in g of x. So that is the same as saying f of x plus 3 equals. And so that's going to equal x plus 3 to the second power. See, I took x and replaced it with x plus 3. So my answer, f of g of x, is just x plus 3 squared. That's it. Because there's no numbers in there, I don't need to get any more specific. Now this one has a number, so I do need to get specific. So let's look at this one. I've got g of x equals x plus 3. So now I got g of 2, because that's what I want. G of 2 equals 2 plus 3. That equals 5. So now that I know g of 2 equals 5, so now I want f. So let me put f of x first. F of x is x squared. So I want f of 5. Let me make sure you understand. G of x is x plus 3. I want g of 2. So I replaced x with 2. Got 2 plus 3. 2 plus 3 is 5. So now that 5 is what goes in here. So f of 5 equals 5 to the second power. So that equals 25. And that's my answer. All right. And then last but not least, determine end behavior of the rational functions. So what I do when I'm dealing with this is I want to break down my expression, and then I put in values to see where it goes. So the first thing I'm going to do is say, what is significant about the top? What about the numerator? Well, that minus 9 in the big scheme of things doesn't really matter. As x starts getting bigger, that minus 9 is going to fall off. So I kind of think about that as, okay, x to the fourth is important, the rest of the stuff isn't. And then I look at here for the bottom, x to the third. Well, as x gets bigger, the 4 is going to be it's going to be inconsequential. It's not really going to matter. So I've got x to the third, and I'm just going to put some dots. So now that's what's significant about my function is the x to the fourth, the x to the third. So what am I going to do? I'm going to treat that like that's the only thing I got, and I'm going to simplify it. That just gives me x. So now, if x is pretty much what my function, kind of breaks down to, I'm going to say, well, what if I take x to infinity? What is my function going to go to? So I'm going to say f of x. Because remember, when I'm dealing with a function, x is my input, f of x is my output. So if my function goes to infinity, my answer goes to infinity. So if my input is infinity, my output is infinity. If my input is negative infinity, then my output is going to be negative infinity. What that's saying is, if I plug in numbers that keep getting bigger and bigger, is there anything there that's going to change this? No. If I go to positive infinity, if I'm putting in bigger positive numbers, I'm going to get a big positive number. If I put in negative numbers, going to negative infinity, so I keep putting in these smaller negative numbers, I'm going to get a small negative number for my answer. That's the point of this. Now, why do I care about this? This isn't part of the problem, but we're gonna make this gray and just make the point real quick. Because if I had something like x squared is my my end all function or whatever, and I was putting in positive numbers, well, I'm gonna get a positive number. But if I put in negative numbers, I'm still gonna get a positive number. I'm still gonna get a positive number. All right, I'm still gonna get a positive number. That's why I was saying it may seem kind of silly. Well, why are we doing this? Well, because sometimes you may have a situation where you put in a negative number and you're going to get a positive number because x squared. If I put in a negative 5, x, negative 5 times negative 5 is positive 25. So in that case, as x goes to negative infinity, my answer will go to positive infinity. So this isn't a problem, but I want you to understand what this situation means, because it's not always just infinity, infinity, negative infinity. But that's what end behavior is. Okay. Now I was gonna go back and tell you what sections this fell under, but I kind of botched it the last time I did the video, so I'm gonna stop right here and then I'll make the next one. Okay.